We're launching this deep dive with a number that is just, well, it's truly staggering. Nearly $50 million in USDT.
50 million.
And that immense sum vanished because of, well, what is frankly a low-tech exploit of a universal human habit.
The copy-paste.
Exactly, the convenience of copy-paste.
It's a terrifying paradox, isn't it? Because when people hear about major crypto thefts, they immediately picture these complex DeFi exploits or hackers cracking private keys.
Right, something super technical.
But this was entirely different. This was a massive crime executed by exploiting a basic, everyday user interface feature.
Okay, so let's unpack this. We are looking at one of the costliest user errors ever documented on the blockchain. Our mission today is to dive deep into the mechanics of what's called address poisoning. We want to understand exactly how a single moment of just routine behavior led to this irreversible catastrophe.
And we have really detailed on-chain analysis for this. It confirms the entire movement of the funds, charting the exact sequence of events. For you, the listener, the goal isn't just to understand the exploit itself, but to maybe understand your own digital habits a bit better.
Yeah.
We need to internalize how these routine actions, like copying a familiar-looking address from a history feed, can just instantly nullify otherwise cautious behavior.
Especially with the speed and, the finality of blockchain transactions, there are no takebacks.
None.
So let's start the narrative with the victim, because this wasn't a rookie making a high-value mistake.
No, not at all. The sources confirm this was an experienced individual, and they actually followed what is considered, a gold standard of crypto safety.
The test transaction.
Test transaction. They made a small one first.
How much was it?
They sent a tiny amount, just 50 USDT, to a personal destination wallet. This is the definition of best practice. You confirm the address works, you confirm the network is correct, then you send the big amount.
This whole approach was meant to ensure security.
Exactly. But tragically, that small transfer, that became the central piece of information the attacker needed.
And here's where it gets really interesting, because that cautious test transfer instantly signaled to the waiting scammer that a much larger transfer was probably coming.
And it gave them the exact verified destination address they needed to spoof.
The timing is just incredible.
Oh, it's automated and precise.
Yeah.
Within the time it took for that 50 USDT transfer to confirm, the scammer deployed the address poisoning tactic.
How? How did they do it so fast?
They had pre-generated a massive batch of what are known as vanity addresses, just hoping to match the victim's genuine destination.
Okay, wait, can we pause there? Vanity addresses, that sounds much more sophisticated than just a random generator. What are they exactly?
That's a key detail that often gets missed. A standard wallet address is, a 42-character string of letters and numbers?
Right, impossible to memorize.
Generating a functional address that just happens to match your target's first 4 and last 4 digits randomly. It's astronomically difficult.
So they're not just getting lucky.
No. Attackers use specialized software to just continuously brute force generate addresses, millions of them, until they find one that partially matches the target's address.
So it's a calculated, automated effort. They're investing compute power to create a look-alike.
Precisely. They create a vanity address that looks cosmetically identical when, and this is key, when it's truncated by a wallet UI.
The ...
The ... So once they had their matching fake address, the next critical step was manipulation. They sent a tiny, negligible transaction from this fake address to the victim's sending wallet.
And that small, meaningless transaction had one monumental purpose.
To get on the list.
To ensure that the scammer's fake address was officially recorded in the victim's transaction history, sitting right there at the top.
Right alongside the legitimate 50 USDT test transfer.
So when the victim returned to send the main amount, that eye-watering $49,999,950 USDT.
They didn't go back to their original address book. They didn't re-verify the full string.
They just opted for convenience. They copied the address from the wallet's recently used history feed.
And this is where the wallet design becomes the villain in the story.
Because most modern wallet interfaces are designed for readability, so they truncate the 42-character string. They just show the first few digits, a ... and the last few digits.
We've been trained to trust that view. The victim does a quick habitual visual check, sees the matching ends of the address, assumes it's the right one.
They click send.
And the money is transferred instantly and permanently to the hacker's vanity address.
It's a failure of routine overriding vigilance, and it's amplified by a design decision that saves a little bit of screen space but costs, well, in this case, $50 million. dollars.
Let's dig a little deeper into the core mechanism here. You mentioned it's basic compared to Defy exploits.
Yeah, it sounds almost too simple to work.
It's basic in the sense that it doesn't exploit a flaw in the blockchain's code. It exploits the weakest link in any system,
The human.
the human-computer interface.
Mm.
It relies entirely on behavioral patterns, specifically things like confirmation bias, coupled with the fact that we are just not good at processing long strings of random data.
We're not wired to read and memorize a 42-character string every single time. And the wallet designer makes a rational choice to abbreviate it to make the app usable.
But that choice creates a systemic vulnerability.
Wow.
They're basically encouraging this partial verification. So the moment the attacker generates those partial matches, they have weaponized the wallet's user experience against the user.
And that's why analysts were so shocked, not just by the scale, but by how effective this low-effort, high-return strategy was against someone who was trying to be careful.
Exactly.
I have to admit, I do this. I check the first few and the last few digits every single time. I'm relying on that truncated view.
We all do.
This case is a horrifying reminder that my own cautious routine is exactly what the scammer is banking on. The irony is just, it's suffocating. The test transfer, meant to confirm security, was the signal that put the killer address right at the top of the history feed.
And this highlights why seconds matter. If the user had taken, an extra 5 seconds to copy the address from their original saved source, not the history feed,
The loss would have been prevented.
entirely.
Yeah.
But that instantaneous pull toward convenience, which is driven by the UI, that was the tipping point.
That shift from vigilance to routine is terrifying. But okay, let's look at the flip side. What happens when the funds land? Because the hacker was moving with remarkable efficiency.
Oh yeah, the blockchain records confirm the funds did not sit idle for a minute.
Not a minute.
The moment that nearly $50 million landed, the plan for obfuscation immediately kicked in. We saw analysis from Look on Chain showing the funds were almost instantly swapped.
Swapped for what?
A significant portion of the USDT was exchanged for ETH. That immediate swap is step one in cleaning the money. You move it out of the stablecoin and into a more liquid, more frequently mixed asset like Ether.
And then came the routing, I assume, to diminish traceability?
Yep. The funds were routed through several intermediary wallets in rapid succession. This multi-hop technique is a classic way to try and break the chain. It makes it harder for any single firm to flag the entire movement.
So this wasn't opportunistic. They had a plan.
They had a well-oiled machine ready for the exit.
And the final destination, where did it end up?
Well, significant chunks of the assets ended up in Tornado Cash.
Tornado Cash. For listeners who might not be familiar, what does using a privacy mixer like that actually imply for recovery?
Tornado Cash is a decentralized privacy mixer. So in simple terms, you put your assets like ETH in, and it combines them with the assets of hundreds of other users.
It muddies the waters.
It completely breaks the transactional link between the input wallet, the hackers, and the output wallet. When you withdraw your assets later, they come from a different, unassociated address.
Making it the point of no return.
Exactly. Recovery becomes virtually impossible unless law enforcement can somehow halt the funds while they're still inside the mixer, which, rarely happens.
So the speed of this whole thing shows they were just ready to execute the second that transaction confirmed.
They were ready, the trap was set, and the exit plan was in place.
This entire scenario, it really forces us to look closely at the tools we use every day. If the UI is actively creating this security hole, it raises an important question. How much does Wallet UX actively contribute to a $50 million security failure?
It contributes significantly. Wallet designers are under immense pressure to make the complicated world of crypto feel manageable.
Sure.
And truncated addresses are a design solution that prioritizes visual clarity. It makes the interface look less cluttered, more digestible, but that choice, it fundamentally reduces security for high-value transactions.
Because it teaches us to rely on a partial verification method that is easily exploited.
It's the ultimate trade-off, isn't it? Speed versus safety. And in this case, speed won disastrously.
And that realization is critical. Reliance on visual checks alone is it's not enough for high-value transfers.
And this incident proves that even highly experienced users dealing with huge amounts of money can be rushed or just fall into these predictable patterns that scammers are designing their bots to capitalize on.
The scam works because it exploits the predictability of our behavior.
Yes, under routine circumstances, we are very predictable.
So if this is a known scam, and it can obviously carry a $50 million price tag, what is the industry doing to address it? Is the response adequate?
The response is
Uh,
evolving,
uh-huh.
but it is deeply inconsistent, which is a problem.
Okay.
Some more security-focused wallets are starting to implement specific warnings. They might flag when a copied address closely resembles another one in your history, or if an address has recently sent you a tiny transaction.
But that's just a warning. People click through warnings all the time.
They do. It often just throws up a generic message. It still relies on the user not having that momentary lapse.
So that sounds like a bit of a band-aid fix. What about features that truly eliminate the risk, even if they make things a bit less convenient?
The gold standard for prevention here is address whitelisting.
Whitelisting.
This feature completely eliminates the poisoning risk. Whitelisting restricts all outbound transfers only to a fixed list of pre-approved saved addresses.
So you have to manually add and verify an address before you can ever send to it.
Exactly. And to add a new address, you often need to go through multi-factor verification, and sometimes there's even a time delay before that address becomes active.
That sounds like an excellent safeguard, but I imagine it introduces a lot of friction for the user.
That's the core hurdle. Users often prioritize freedom and speed. Whitelisting requires extra steps, planning. It's like a cooling off period, which kind of goes against the whole crypto ethos of instantaneous transfers.
Sure.
If the victim in this case had been forced to use a whitelisted address, the scammer's spoofed address would have been completely irrelevant. The wallet would have just rejected the transfer immediately.
But most users, operating under time pressure, will always choose the faster, more visually clear solution.
Not realizing that what looks convenient might be a multi-million-dollar vulnerability. It creates this vicious loop. Designers make the UI look simpler to get more people to use it. But that simplification inherently creates vectors for attacks that rely on human error.
Okay, so let's wrap this up with the core lesson here for you, the learner. This attack was successful not because of some genius coding exploit,
No.
but because of an immediate automated exploitation of a convenient interface feature combined with a single tragic moment of human routine.
And the takeaway is stark. The speed and finality of the blockchain mean there is zero margin for error. The test transaction, the history feed, the truncated address, all seemingly helpful elements were turned into perfectly timed weapons against the user.
It completely changes how we should think about digital caution. It moves the focus from, say, securing your private key to securing your habits.
Your habits, exactly. And based on this devastating case, consider the ongoing tension in the industry. If address poisoning is a widely known scam, and we know that truncating wallet addresses increases this vulnerability, should the burden of checking every single one of those 42 digits fall solely on the user?
Or should the platforms be forced to step up?
Right. Should platforms be mandated to implement non-optional security features like whitelisting, even if it compromises that sleek, fast UX? What does true safe UX really look like when $50 million is demonstrably on the line?
That's the debate, isn't it?
That is the regulatory and design debate that this theft is just violently brought to the forefront.